Hello students, so we'll continue the class. So in the last class guys, we had discussed about what? We had discussed the cause of friction. Okay, we had discussed about what? Cause of friction. And I was planning for what? I was planning for to discuss about what the type of friction, so that I couldn't do study guys. So today we are going to discuss that. Okay, so guys, let's discuss with what? The type of friction. Okay, let's discuss about guys what? The type of friction. So let me write down guys, type of friction. So guys, if we talk about the type of friction, there are mainly two types. Okay, static friction, and guys the second one is what? Kinetic friction. Okay, kinetic friction. So guys, let's first talk about what? The static friction, and then we will talk about the what? Kinetic friction also. Okay, so guys, let's talk about the static friction. Okay, so guys, I'll just write the definition of what? The static friction. That which friction we will call, or which state of friction we will call as a what guys? That this is belongs to static friction guys. So here I'll just write down guys, the force of friction applied by one surface to other surface when there is a possibility of motion, but motion is not happening. What I'm trying to say guys, try to understand this. What I'm saying, that motion is not happening, rather it is what it is guys, what it is, that there is a possibility of motion. Okay, means impending motion that I talked about in the start. So guys, when this is the condition, then at that moment whatever the friction force is acting on the particle or on the body, that would be guys known as what? Your static friction. Okay, what does it mean? Let's try to understand this a little bit more deeper. Okay guys, so let's say suppose guys this is the surface. Okay, so guys here what happens, suppose this is your block. Okay, and guys, if I say, let's say you applied 2 Newton in this direction, and guys what you are observing that there is no motion. So of course guys, that should come in your mind that okay, if it means there is no motion is happening, it means that this 2 Newton should be getting countered by some other 2 Newton in the opposite direction. That is the thing. And guys, if it is happening, it means what? There is only one force that could act, that is what guys? Friction force, because there is no other force externally acting on the body. Okay, so it means guys what? It means that right now the applied force by the friction is how much guys? 2 Newton, which is just stopping the what guys? The possibility of motion. Okay, which is just stopping what? The possibility of motion. Now guys, let's say if you applied what? 3 Newton, and still you are seeing that there is no motion is happening. So it means what guys? The friction force shifted from 2 to 3 Newton to just stop the what? Possibility of motion. But guys, let's say you applied the 4 Newton. Okay, and guys what I'm saying, let's say guys you applied the force of how much guys? You applied the force of 4 Newton. Okay, you applied the force of what guys? 4 Newton. And what you are seeing is that your body, okay, your body guys starts moving now. Okay, your body is guys what? it's now start moving. Okay, it is going to, guys, what, it is moving now. Okay, it is moving now. Just give me a second, guys. Okay, let me try this. So guys, this is what, this is starting what, guys, moving with this. Okay, if I make properly, like, let me try this animation. Okay, so 1 minute is like this way. I'll club these two, and now guys, if you see, this is what, this is moving along this. Okay, so guys, something like this is happening. Okay, so now the question will come that, sir, why it started the motion at 4 Newton, why it's not at 2, or why it's not at 3? Okay, so guys, let's try to understand the mechanism of this thing, that what was happening at a molecular level when you are applying the 2 Newton or 3 Newton. Okay, so guys, if you remember in the last class, okay, when I was discussing about the cause of friction, there, guys, I had talked about something very important. Okay, what, that the intermolecular forces are the main cause of what, guys, of the friction force. Okay, so guys, here if you see, if I show you the force, sorry, the intermolecular bonds, guys, these were intermolecular bonds which were formed. Okay, so guys, when we were applying the force, okay, when we were applying the force of 2 Newton, guys, 2 Newton force we were applying, so guys, the body was trying to move in this direction, but these bonds were getting what, guys, elongated like this, and due to this elongation, guys, the 2 Newton force was coming in this direction, which was just holding what, this body. Basically, it's like, guys, what we can say, hooks are there. Okay, these hooks are what, stretchable. Okay, so when we are applying the 2 Newton, there is a elongation is happening in the hooks, and guys, the 2 Newton force is getting generated in the opposite direction, and due to which the body was not moving. When you applied, guys, 3 Newton, then again the elongation becomes little bit more in the, guys, what, these bonds, and the 3 Newton force came into this side, and guys, again what, the body was not moving. Okay, so guys, there is a some capacity of these bonds to hold these forces, okay, which we were applying. Okay, so guys, if let's say, guys, that bond capacity was 3.5 Newton, guys, if let's say this bond capacity is what, guys, 3.5 Newton, it means, guys, what, if your force has gone from 3.50000001 also, like this way, okay, then it means what, your body had the body will start the motion. Okay, that was all the thing that we wanted to talk about. So guys, if you see, till 3.5 Newton force if you were applying here, the body was not going to move. It was just guys, what was happening, the friction force was just acting that much, so that body's state of rest would be maintained. Okay, that was the whole thing. So guys, try to understand static friction here, guys. If I summarize the idea, static friction always, guys, what, static friction always tries to stop the possibility of relative motion, possibility of what is relative motion between the surfaces, okay guys, and there is a limit or the capacity of static friction up to which it can stop the impending motion, okay, or possibility of motion. This capacity, guys, this capacity is known as limiting friction. This capacity is known as, guys, what, limiting friction. This capacity is, guys, known as what, limiting friction. I hope you understood the idea that I wanted to talk about, guys. Okay, so now, guys, because you have understood the idea, I'll take a problem so that I can make this thing much concrete. Okay, so So let me take a problem here, okay, or okay, let it be right now. Okay, we'll discuss this thing later about this problem thing. Okay, problem I'll take later. Okay guys, okay, so this is all about, guys, what the static friction force. I hope you understood. Okay, I hope you understood. So guys, if I make a graph of static friction, okay, if I make a graph of what, guys, static friction, so how it would be, guys? It would be like, guys, this. Let's say this is F static. Okay, I am representing like this. S in suffix means static friction, guys, and this side, guys, what? F applied. Okay, F applied. So guys, if you see what was happening, if you see, guys, when we were applying, guys, let's say 1 Newton, friction was also coming, guys, what? 1 Newton. It means there is a 1 dot, guys. Okay, when we were applying, guys, what? 2 Newton, friction was also coming, guys, what? 2 Newton. So guys, second dot. Okay, if, guys, we were applying what? 3.5 Newton, guys, then because 3.5 was the capacity, guys, it will go up to, guys, what? 3.5 Newton. So guys, if you see till its capacity, if you see whatever the force you will apply, that much force it will apply from its end. Okay, so that the possibility of motion could be stopped. Okay, the possibility of relative motion could be stopped. I hope you understood the idea of what, guys, static friction in a proper manner. Okay, now, guys, I think I have covered the idea of what? Static friction, and the what is the idea of limiting friction, okay, that I have discussed. Now let me discuss what the kinetic friction. Okay, so guys, let's move on the next thing, which is what, guys? The kinetic friction. Okay, so kinetic friction, kinetic friction. Okay guys, kinetic friction. So guys, I am going to write, or I am going to represent this with what? Fk. So F, guys, for friction force, and K for what, guys? Kinetic. Okay, so it is what, guys? Kinetic friction force. So guys, try to understand. When, let's say, guys, this is the situation and this is your block, guys, and let's say you have applied the 4 Newton force, guys. Okay, with the previous reference that we had discussed, from there only, guys, I am going to talk about. So guys, what we observe experimentally, what we have seen, guys, that what happens here, that this force would actually, if I take some other color, guys, just to show, guys, please pay attention, guys. If, guys, this force, like, our intuition would be what, guys? That it should be what? It has gone to its limit, that is what? 3.5 Newton. So that was its capacity. So it should be what, guys? 3.5 Newton only. That is what? That should be our like a general intuition that we will be having. Okay, that okay, if I will apply 4 Newton or 5 Newton, nothing much is going to happen, guys. Just friction will apply how much? 3.5 Newton, and that would be what? Your friction force. Nothing there much is going to happen. This would be the case. But guys, what we have observed is that experimentally it has been found, guys, that this force falls from here. Okay, it falls from here, guys, and it does not stay up to 3.5. It falls from here and it drops from 3.5 to a little bit lower than that. Okay, it could go up to what, guys? Let's say we can say up to 3 Newton, or maybe 3.2 Newton, or something like this. Okay, so guys, actually the picture would be what? The picture would be something like this. Okay, the picture would be what, guys? Something like this, that now if you apply the 4 Newton or 5 Newton or 6 Newton or anything, guys, here there is a constant force we observe in the backward direction, and that force is how much, guys? That is 3 point, let's say, 2 Newton or something like this. Okay, so guys, this force that is appearing during the motion of the body, okay, during the relative motion of the body with respect to the surface, or we can say during the sliding between the surfaces, is known as, guys, what? Kinetic friction force. Okay, so let me write down this idea, that, guys, what? The friction force, the friction force that acts between the surfaces, when the when the when the relative sliding relative sliding relative sliding starts between the sorry guys relative sliding starts is known as kinetic friction force, and this force on average during the relative motion remains constant. Guys what? Constant. So here two things guys I had said. One is what? On average. What does it mean guys of this? I'll talk about. Okay, and guys what? Of course remains constant. Okay, so guys let's try to understand what is happening here. Okay, in this case, so guys if I say what would be the graph for kinetic friction guys, so let me write down like this way guys. If I make the graph of kinetic friction, okay, if I make the graph of what guys? Kinetic friction. So guys let's say this is what? Fk. So guys till the force applied is what guys? 3.5 Newton. Till that you will not see any force that is what is going to change the, like there is no relative sliding is going to happen till that. Okay, but guys as you increase the force from 3.5, what is going to happen guys? The sliding is going to take place. So guys this sliding which is going to take place, what will happen guys? I have told you that the force will become almost what guys? 3.2 Newton. Okay, so guys actually what happens here, that this force is not 3.2 but little bit what here and there it drops. Okay, so you can say it goes from 3.2 to what? Maybe 3.15 or 3.25, something like this guys. There would be a bit changes would be happening guys. But if I show you guys that on average guys, if you see on average this is the case. Okay, on average this is the case only. That is what guys? 3.2 Newton only. Okay, this is what? On average 3.2 Newton only. Okay, so this is going to be the case guys. So if I club these both the friction forces guys and I make a graph, then how the graph will look like guys? Just let's see. Okay, so guys if I make the graph by combining both the friction forces, that is what guys? Fs and Fk. So guys if you see, this is what guys? Fs or Fk, and this is what guys? F applied. Okay, then guys here what I will show like this the graph guys. What? That guys up to 1 minute guys, I think there is some problem. Guys see, so up to guys F limiting. Okay, F limiting guys, F limiting, this would be the case. Okay, up to F limiting this would be the case guys. And F limiting belongs to guys what? Static friction. Remember guys, F limiting is what guys? Verge of static friction. Okay, verge of static friction, remember always. Okay, verge of static friction. And guys after that as your force exceeds, okay, after that guys as your force exceeds, what will happen guys? The friction will drop from its value and it will become what guys? It will become, let me choose some other color guys so that I can show this in a better way. So guys after that suddenly guys friction will drop and it will become what guys? Something like this kind of a curve. Okay, and that guys this on average would be what? Almost constant. So we can make this kind of a curve guys, and this force is what guys? Your Fk. The pink one guys what? Fk, that is what? Your kinetic friction force. And of course yes guys, in the x-axis we are applying what? F applied. So guys this is what? Your kinetic friction force. I hope this also you have understood. And guys, maybe you could ask this problem, could ask this doubt, sir, why this ripples are coming in the kinetic friction graph? Okay, that might be a question. And why this is constant, guys? This also might be a question. And this also might be a question, that why it has been dropped, why it is not the same. Okay, so guys, let me try to explain that also for you, and then that's it for today. Okay, so let me explain that, and then we'll wind up for today's. Okay, so guys, if you see, if I take, guys, what, this is your what, the bodies. Okay, now guys, try to understand, this is very much like a fine explanation that you have to understand. Okay, see, so guys, these were the bonds earlier. Okay, these were the bonds earlier, but guys, if you see, if this body, guys, it starts moving. Okay, if, 1 minute, guys, let me do like this. Guys, if you see, when this body, guys, starts moving, of course, guys, what is going to happen, these bonds are going to break. These bonds are going to what, guys, break. Okay, and when these bonds are going to break, guys, so of course, guys, when they this block is moving, when this block is, guys, moving, the other bonds. Okay, let's say if I'll make a one more picture so that I can explain this thing. So guys, suppose when your block reaches here, okay, when your block reaches here, guys, there would be some bonds will form here also. But guys, these bonds during the motion, these bonds which are getting formed during the motion will not be that strong. Okay, why, guys? Because see, earlier the body was settled. Okay, and there was a proper time that these molecules were getting to what, to settle these bond formation. Okay, but guys, because the body is continuously moving, so here we can say a lot of other complex mechanisms are also happening, guys, but we can understand in terms of time factor that because the body is continuously moving, guys, so it is not getting enough time to form the bonds properly. Okay, so bonds formation is also happening and bonds breakage is also happening. Okay, so guys, effectively on average there is a what, some net, what we can say, some net force of intermolecular interaction is happening between the mass and the surface. Okay, so guys, of course, that force would be lesser than what, the initial force. That's why, guys, what we can say, the kinetic friction force drops. Okay, that is the first thing. Second thing is, guys, what, because we know that the surface is not everywhere what, same. Okay, there is unevenness everywhere is there. Okay, so guys, somewhere if proper bond formation happened, so a little bit more force you will see, okay, as a kinetic friction. And somewhere, guys, if let's say the proper bond formation did not take place, so guys, a little bit lesser force we will see. So somewhere, guys, on average it would be same, but a little bit here and there minute changes we can see in the kinetic friction force. So guys, this is the explanation of what, that how the kinetic friction force has been dropped and why these small ripples are coming in the graph of what, kinetic friction force. I hope you understood. So guys, that's it for today. Okay, we have discussed what is, guys, what static friction force and what is kinetic friction force. We have seen the graph of that, and we have also understood what is limiting friction. So guys, in the next lecture we will talk about what, we will talk about the quantification of what, guys, the friction force. Okay, so till this we have just done the qualitative analysis. Tomorrow we will do the, guys, what, quantitative analysis also. Okay, guys. Okay, thank you so much.